Now, since we made the Rook, I've had a few questions about 5-spoked poles, what they do and why they're bad, so I thought I'd talk about them here. The first thing is, 5-spoked poles are not bad. They're essential to describe complex shapes. The problem is, a lot of modelling tasks leave them in the wrong place where they can cause a lot of trouble. Let's have a look at it in its simplest form. I'm just going to delete the default cube and press Shift and A to add a mesh plane. Now I'm going to tab into edit mode and right click and choose Subdivide. Just to give it a little more geometry, I'm going to give it 2 cuts. Now, if I press Ctrl and R to add loop cuts to this surface, you'll see yellow lines showing where they go as I hover over the edges. And it's obvious where they'll go. It's all very sensibly arranged in quads. Okay, but what if I introduce a 5-spoked pole to this? The easiest way to do this is just to select 2 corner points in the middle face and press J to join them. Now I'll right click and say Subdivide, which just subdivides that edge, which keeps everything as quads. Now if I press Ctrl and R again to add loop cuts based on the edges I hover over, we'll see that the ones around the edge are still very easy to predict. But if I hover over this edge, you'll see that the loop changes direction completely. This is how we change flow around surfaces. It's very useful and completely necessary. But if I hover over this newly created edge, the loop that it wants to create goes off around in a completely different direction. These ones go all around our 5-spoke pole, but this one goes a different way altogether. There's nothing we can do about this. This is how topology works. But what it means is that there's a new direction of pull away from our vertex here, and it causes problems, especially when it's on an area of curvature or a corner. So we do our best to keep these 5-spoke poles on as flat an area of the mesh as we can find. Now that's not a very useful demonstration of anything you'd want to create in 3D, so let's start to think about how they actually turn up, and what we need to do to control them. Let's just start a new scene and delete the default cube. Again, I'm just going to add a mesh plane, and let's subdivide this one. I'm going to give this one 5 cuts. Now tab back into object mode, press Ctrl and 3 to add a subdivision surface modifier, and tab back into object mode. Press 3 on the keyboard to switch to face select mode, and I'm just going to select this face here. I'll press E to extrude, and then extrude up this single face. And Blender creates this new geometry to give this kind of unpleasant looking bump. I'm just going to type 0.5 and hit enter to make it that height. It's a really common task, but we've already made a mistake. If I turn on the on-cage button in the subdivision surface modifier, we can see the geometry more clearly. I'll just change to point select mode and we can select one of these points. As we can see, we've created these 5-spoked poles, and they live on the area of maximum distortion within our geometry. It's the worst place for them, which makes future modelling tasks around this point tricky, confusing and difficult to control. Now it will cause some minor rendering issues as it is, but that's not the main problem. The topology looks a little unnatural, but again that's not the main problem either. The curvature spreads out to whatever the next row of edges happen to be, and that is slightly more of a problem. If we want to control the softness of the curvature into the shape, we have to add loops which are flung across the entire mesh, affecting the shape of anything in their way, and this can be very problematic. You'll see that if I add these loops here to control the curvature into the shape, that we have these 4 loops which spread across our entire surface, and when you have a big complex surface to model on, this is a real problem. They all need to be adjusted individually to control what should be a single aspect of curvature. Let me just undo a few times to get rid of those. They're no good to us at all. Now we can control half of the connection into the curve to tighten it up from the inside of the shape, but this affects the shape above it, and you often don't want that. And the curvature is still spreading out all the way to the edges of the next faces. We have no good control over this extrusion at all. Now the explanation for these problems was long, but the solution is really short and simple. Now I'm going to select this face, but before I extrude it, I'm going to press I to inset it. Now because this makes our face a little smaller than the other one, I'm going to press O on the keyboard to change it to an outset, which is largely ignored and very much underused in modelling. It's a very powerful part of insetting when designing and modelling anything, and in our case we're using it to keep our extrusion exactly the same size as the other one, and at the same time we're deciding where the curvature up into the extrusion will start, and we've pushed the 5-spoked pole onto the flattest part of our mesh. And now that we've created this new border, we'll see that our face is surrounded by points with only 3 edges coming out of them, which means when we extrude this face up, the area of curvature will be converted into vertices with 4-spoked poles. And as I move the new face up, you'll see this really tidy arrangement of polygons around our extrusion. They all flow in the same direction. Everything looks good. I'm just going to type 0.5 to make that one the same height as the other one. If I change to edge select mode, I can add a control loop in this new border which directly controls the curvature of the connection. And you know I love to do it. I'm going to mark it red to signify to myself that this is a control loop and it doesn't affect anything else anywhere on the mesh. We can't do that on the other one. There are no loops to select. And on this one I can always just press GG and slide this loop in and out to control the curvature exactly. Now, while modelling the shape above the connection area, you'll still use all the normal processes of extruding regular polygons to get the shapes you need, and having 3 and 5 spoke poles within a shape is completely normal, but now we have a much better connection between these shapes. So I could perhaps add 2 loop cuts here, and do the same on this one. Go to face select mode, select both of those and just extrude them out, and we see that these 2 shapes are the same, but this one has a much better connection area. And because I don't have any loops to select here, I would have to add tightening loops around the edges. And you can see these go straight across the entire mesh, and they'll affect everything in their way. Now in object mode, you can see this one does look much better, but the new loops I added didn't seem to cause any problems because it's a very flat area. So you may be wondering why these loops, which go all the way around our mesh to tighten things up, are so bad, beyond looking a little bit messy in edit mode. So let's start a new scene and make a simple object which will undergo some distortion. So let's take the default cube, tab into edit mode, subdivide it, and give it 2 cuts. What I want to do is in face select mode, I want to select all of the center faces around the mesh, rather than having to spin the mesh around selecting all the faces, which can be tricky if they're obscured by other things. I can just select these 3 faces here and use something called the select mirror tool, which just selects opposing faces across the 3 axes. So if I press Ctrl Shift and M to activate the tool, and in this little box I'll click Extend, which just means other faces will be added to my selection, and then I shift and click the Y and Z axes, all of the faces will be selected all around the cube. That's just a quick way to do that. Now if I go to the extrusion tool in the toolbox and hold down the left mouse button, I can change the type of extrusion to extrude individual. And now I can use this little yellow circle just to pull out all of these faces along their normals. I'm just going to type 1 meter as the offset. Then I'm going to go up to the Transform Pivot Point menu and change everything to Individual Origins, because I'm going to scale these faces all individually around their own centers. And if I press S, you can see they get smaller and bigger around their own centers, and I just type 0.2. Now I'm going to tab to Edit Mode and press Ctrl 3 to add a subdivision surface, and we have this simple but interesting shape. So set it to Shade Smooth, and that might be just what we want. If I turn on cage, we'll see that we have this 5-spoke pole here, and it's not a huge problem. The only problem comes if we want to change the softness of this connection without changing the shape above it, and that happens all the time. We now have to do it by adding tightening loops, which go all around the mesh, and they're all affecting each other, which in this case is actually quite beneficial, but generally it won't be. Now if we look at it, the connection looks fine. It's perhaps a little square at the edges, but that could be the shape you want. But now if you want to distort this mesh with either modeling tools or animation tools, these loops are going to cause us problems. Now let's make this into a kind of a soft body and drop it on the ground and see what happens. First we're going to need a floor to drop it on, so just press Shift and A and add a mesh plane. I'm going to press S and type 30 to just scale it up. We'll select our mesh, move it up, and Z, and maybe rotate it a little so that the fall to the ground is a little more interesting. Now let's quickly set up the simulation, which is normally done using the cloth system, not the soft body system. Cloth's better than soft body in lots of ways. It's more stable, it's faster, it's interruptible, and I would always use cloth for this kind of simulation. Soft body most certainly does have its uses, and I'll talk about those in later tutorials, but cloth simulates soft body significantly faster than the soft body system itself. Now first of all, let's select the floor. I'm just going to press F2 to rename it floor, and we go to the physics property panel, which is this small blue circle. Now I want this floor to be something that our object can collide with, so I'll click on collision, which makes it a collision object. In the properties that appear, I always change the thickness outer and the inner to their absolute minimum values. Blender can always handle these being set to their minimum values, and that gives us the best results. I might change the friction to 30, which stops everything sliding around, but I'll leave everything else alone. Now let's select our shape. Now we want this to be a piece of cloth, so I'll click on cloth in the physics panel, which adds all of these controls. It looks complicated at first, but for our needs it's not. We'll set it up so that we only use really 2 or 3 of the properties to play with our shape. And in fact only one of the properties does all the hard work. Now before we look at any of these properties, we need to go to the modifiers panel by clicking the blue wrench and make sure that the subdivision surface modifier is moved after the cloth. This is really important, and you won't get good soft body results without doing this. The subdivision surface modifier should always be the very last thing in any stack. Now let's go back to the physics panel and we can change some settings. Now before we do, let's just take a look at the dimensions of our object. It's 4 meters across, and Blender's cloth system generally likes to have things that are between 1 and 10 meters in size. That's the area in which the calculations work best. You can go above and below this, but somewhere between 1 and 10 meters is ideal. The problem with those sizes in the cloth system is that everything appears in slow motion, so I normally like to change the speed multiplier to between 2 and 3. I'm just going to make it 2.5. And because we're doing that, things are moving a little more quickly, so we need to increase the quality. I normally start at around 15. The next thing we need to change is the vertex mass. It's just too light. A good starting point is 20 kilograms. I often just leave it at 20 kilograms. It can be changed to get other effects if you're not getting quite what you want, but 20 kilograms works really well. We don't need to change the air viscosity. It has very little effect at this scale. The next thing we want to change is the bending method. We don't want it to be angular. We want it to be linear. We use linear for soft bodies and angular for actual cloth simulation. Now, we want to remove some things from consideration by the cloth modifier altogether, and we achieve that by setting them to their absolute maximum values. So in structural, we'll set it to 10,000, which is the maximum it allows. We do the same for shear, 10,000. And bending, which is one of the controls which we will actually use, we set to somewhere between 2,000 and 10,000. I'm just going to set this one to 7,000. It's a good place to start. Again, down in damping, we want to remove structural from consideration, so we set it to its maximum value, which is 50. Same for shear, set that to 50. And again, bending and damping is one of the properties we will use, and that generally gets set somewhere between 0.01 and 10. The lower it is, the softer your object. I'm going to make it very soft. I'm going to make it 0.03. And that'll help to highlight what the problems with the tightening loops really are. And we don't need to worry about the internal springs, so we won't turn that on at all, and we won't worry about pressure. Both of these things are slightly simulated just by setting the structural and the shear to 10,000. The cache we'll talk about a little later. The shape we don't need to worry about. Collisions, we need to change a few things in here. First of all, I would always set the quality straight away to 100. Precise collisions aren't a huge overhead in the calculation, and they are the thing most likely to go wrong, so we set the quality to 100. We have object collisions, but again we want to reduce the distance down to its absolute minimum. We need to turn on self collisions. This will help our soft body to keep its shape, and again we turn the distance down to 0.001. At this point you'll often see people adding a small value for impulse clamping, but in my experience that can cause enormous trouble in soft body simulation, so we always leave it set to 0. Now that's everything set up, our object's going to be very soft because I set the bending to 0.03, but let's press play and it'll start to simulate it. And the simulation works very quickly, and if we zoom in, hopefully we can see some of our problems. Wherever we had the tightening loops, we can now see them as ridges around our shape, and that's going to be a real problem in soft body simulation or any deformation of this kind of mesh. They really are quite obvious. In fact, let's set the bending even lower. Let's go to 0.02 and take a look at that. As it simulates, you can clearly see all of these ridges all around our mesh. It's just not good enough. Those edges are changing the actual structure of our shape, and that's what we need to avoid, certainly in soft body simulation. So now let's add another cube by pressing Shift and A and adding a mesh cube, and we'll see if we can make this in a better way. I'm just going to move it up a little, and in edit mode, again I'm going to subdivide it, give it 2 cuts. I need to select all of those faces around the edge. I can just press Ctrl Shift and M again to use the select mirror tool. It'll remember the settings from last time, and it'll select all of the faces around. Now this time, before I extrude, I want to inset the faces. And in fact, because that's making the faces smaller, I'm going to press O and use the outset tool, and just create a nice small border around the faces. Now when I use the yellow circle to extrude them, and just type 1 again as the offset so it's the same size as the other one, make sure I'm on individual origins and scale the faces by 0.2 to create the same shape that we had before. Tab to object mode, press Ctrl and 3 to add a subdivision surface modifier, and we'll take a closer look at this one. We'll see that the polygons flow in a much more natural way all around the extra shape that we've created here. Already all of this topology is much better than the one above. If I tab into edit mode, I can look down here and see that it has 104 vertices, whereas if we check on the other object, tab into edit mode, we'll see that has 176 vertices. It's about 70% heavier, and that means it'll be about 70% slower in the cloth simulation. I'm just going to set this one to shade smooth, and with it selected, if I shift and select the other cube, I can just press Ctrl and L and say copy modifiers, and all of the cloth properties and subdivision surface properties will all be copied into our object. I'm just going to move it out of the way of this other one and press play, and we can see them both being dropped on the ground. And we can see that with exactly the same properties, this one distorts perfectly, in the way you would expect a shape like this to distort. There are no ridges and everything looks very smooth. We could add control loops to tighten this up, and each one can be controlled individually. That's not true in any way of this shape. We can delete all of this, it's rubbish. I just go back to the first frame. I'm actually going to rotate this a little. And I think the object is just too soft. So I'm just going to change the bending damping value to 0.4. Press play to simulate it, and that looks pretty good. That's an interesting object, dropping in an interesting way. We can stop it at any time and just replay and replay. And that looks good enough. Now, one of the benefits of creating much lighter geometry, as you do when you're subdivision surface modeling, is that we have the opportunity to create much more interesting simulations by adding lots more objects to them. Now, what we don't do are duplicate the objects with the cloth systems on them. Separate cloth modifiers or systems on an object don't play well together. The way we add extra objects in cloth simulation is in edit mode. One object contains all of the geometry that the cloth system is going to consider. Press A to select everything, and then just press Shift and D to duplicate this. I can move it up here, rotate it around, duplicate another one, rotate that around, duplicate it again, move one here, rotate it around a bit. I can select them all and duplicate them and move them all over here. And now when I tab back to object mode, go to the first frame and press play, it'll go off and it'll simulate all of the objects bouncing together. And it'll still happen fairly quickly. It's doing about 6 or 7 frames per second, and that is more than acceptable. When I stop it and go back to the start, I can press play and it'll run in real time. Well, it'll run in real time on my machine because I have a new feature just introduced in Blender 3.1 enabled, which is GPU acceleration of the Subdivision surface modifier. If you go to the Edit tab and go to Preferences, in the Viewport section, you'll see a new section at the very bottom called Subdivision, and in there we can tick GPU Subdivision, which means we can have many objects with subdivision surface modifiers applied to them, and it'll play back many times faster than it traditionally has. It really is an amazing new feature. Now, for it to work with any object, the subdivision surface modifier has to be the very last modifier in a stack, which it always should be anyway. And that's all you have to do to enable it, just tick the checkbox so we can close that. And as you can see, it plays back incredibly quickly. Now, we don't have to duplicate the geometry in edit mode. We can join different meshes together and use that as the basis for the softbody, or we can use something like the array modifier to create many softbody objects. I'll switch to edit mode and delete all but one of our objects. I'll just select any element on one of the shapes, a vertex, an edge or a face, it doesn't matter. I'll press Ctrl and hold down the plus key on the number pad and it'll quickly select the whole thing. There are other ways to do this, but it's nice and quick for a small object. Now I'll press Ctrl and I to invert the selection, and just press X and choose Vertices to delete the lot. Now we can tab back to object mode and work there. First of all, I'm just going to reset all the rotations to 0, then I'm going to go over to the modifiers panel and add an array modifier. I'll change the X to 0, change the Y to 0.2, just so that the tower of objects that we get leans over a bit. I'll change the Z to 1, and change the count to, say, 20. Now, very importantly, I need to move the array modifier above the cloth modifier. Now I want to change some of the cloth settings, the two main controls, which are these bending values here. I'm going to set this first bending value to 100 and change the damping bending value up to 10. This gives a really good, fast, soft body simulation, which I use a lot when there are lots of objects. I'm just going to go into edit mode and rotate my shape around a bit, tab back to object mode and maybe make the floor a little bit bigger, and then just press play to simulate it. We can now see the whole tower falling down as individual objects, and they'll all squash together and then bounce away from each other, and it's still fairly fast considering how many objects there are. The more of them that are squashed together, the slower it'll go, but it's still an acceptable speed to change and resimulate things to get a good sense of our animation. Some of the objects might stick together a bit because we have the quality step set quite low while we work. And I see that some of the spikes have actually been pushed inside the shape, which I think I quite like. I'm not going to change any settings in the cloth, this looks okay. But you can really work with it, and you've got the opportunity to change things with these kind of speeds. When you're ready to pull the trigger on your final version, you can set the quality to 50 or 100 and go do something else for an hour while it makes a really good simulation. I'll just stop this now, which you can always do with the cloth simulation, and when you press play again it'll pick up seamlessly where it left off after it's played the cached frames. It's very stable, and because we've got GPU acceleration of the subdivision surface modifier turned on, it'll play the cached frames at real time, even with the subdivision set to level 3 for this. It's a fairly heavy scene, and I can rotate the camera around and zoom in while it plays. Now that's good, but let's just change this a little to get something a bit more interesting. I'm going to go back to the first frame and I'm going to add another array modifier. This time I'm going to change the X to 1.2 just to space them out a bit and change the count to 4. You can do whatever you want. This is really simple. Now move the modifier up above the cloth in the modifier stack. Now I'll press play to start this simulating. And what do we have? 80 objects. There are going to be some mistakes in there. Some things might stick together or bounce off each other in strange ways, but we'll get a good general sense of what's happening in a fairly short time. You might have seen rigid body simulations like this, but with good topology and good settings in the cloth modifier, you'll have the opportunity to make even more interesting simulations like this. It's going to take a few minutes, so I'll pause the video and come back when it's done. Okay, that's done. Let's have a look at that. Great, but maybe let's make a bowl for them all to fall into, otherwise they're just going to fly off everywhere. I'll just add a cube, I'm going to scale it up and move it up, add a subdivision surface modifier with Control and 3, go to edit mode, add a loop cut around the middle. Now I'm going to change to face select mode, select the top face, press X and choose vertices just to cut it in half. I'm going to switch to edge select mode and alt click the top loop just to select it. I'm going to press Shift and S and choose Cursor to Selected. It just moves the 3D cursor in between all of these edges. I'm going to change the transform pivot up here to 3D cursor. Press A to select everything. Press E to extrude and then S to scale it all in a little. Press A to select everything, and then I need to press Alt and N and recalculate the normals outside, because some of them will be facing the wrong way because of the way I made this. I'm going to move it vaguely into position, maybe make it more square actually, with a loop cut here and a loop cut here. I think I'll increase the subdivision level to 4 and then set it to shade smooth. I'm going to make the bowl a collision object just by selecting collision in the physics panel, and again I'm going to change the outer and inner to their minimum values. I'll just look at it from the top view just to make sure it's all above the bowl. It looks okay there, so I'll just focus on the bowl again. Now let's move the array of objects up a little bit in Z and press play to simulate everything. I'm going to fast forward it this time just so we can see the result. So it just took a few minutes to simulate a couple of hundred frames, and I like it, but there are some things sticking together, and that's a good time to increase the quality steps, which stops that from happening. I'm just going to skip back to the first frame, and I think I want to increase the friction on our bowl from 5, I'm going to make it 30. And then for the simulation, I'm going to increase the quality steps right up to 100. Now this is going to take a little bit longer to simulate. It's probably going to take somewhere around an hour. So I'll set that running and come back when it's done. Okay, that's done. Let's just press play and have a look. And that looks great. But in order to change some other properties like subdivision surface modifier levels and even materials, I need to turn this into a bake. Otherwise changing those things will actually reset the simulation. Why those things would reset the simulation I don't know, but they do. So we need to make it into a bake. So if I select the cubes, and over in the physics properties I'll go down and look for the cache, and I need to say current cache to bake. And that just turns this line here a darker blue, which indicates that it's all been saved and it can't really be tampered with at all. It can all still be played back, and we can view it from any angle by moving the camera around and get really close and have a really good look at our simulation. And now we can make it look a little bit better. Let's add an HDRI. Let's go to shading and change to that view. We'll make sure the world data is being displayed. I'm going to press Shift and A and add a texture, environment texture. And I'm just going to plug that color into the background color. I'm going to say open, find an HDRI file. These ones are from Polyhaven and they're all free, which is amazing. So do support Polyhaven any way you can. I like to have a bit of control over my HDRI, so I'm just going to add a vector mapping node to add some controls, and I'm going to connect this vector to this vector. And then I need to add one more node. I need to add an input and texture coordinate just to let the HDRI know kind of where it lives in the world. And we connect generated to vector. And now I can use the Z rotation control to rotate my HDR around if I want to change the lighting. That's quite useful. Now let's go back to our layout tab and change the viewport shading to render preview. I'm just going to move this light out of the way. Let's use the light. Let's make it a bit bigger. Make it an area light. Make it a little bit more powerful. Change the pivot point to median point and scale that up. If I grab the little yellow dot and just kind of point it at any of the cubes, then it'll focus on the bowl. I'll change a couple of settings in Eevee. I'm going to add screen space reflections. Make sure my shadows are a higher quality. And I'm actually going to turn off viewport denoising and maybe increase that to 64. I'm just going to increase the power of this light. And maybe move it up. And that looks pretty good. Let's add some materials to our scene. Let's select the floor and add a new material. I'll just call it floor. I'm going to change the color to make it quite dark. Maybe make it a little bit green. Decrease the roughness slightly. And maybe I'll select our bowl. And let's add a new material for that. I'll call it bowl. Let's change the base color. I'm going to do it in hex. FFD 500, and that's quite nice. Maybe make it a little bit shinier. Select our cubes, add a material for those. I'm just going to call it cubes. Let's change the color again, and for this one I'm going to use 005 BBB. Very nice, and make those very shiny as well, just because it's fun to see shiny things on the screen. Have a look at that, and we can see everything bouncing around. That was great. I'll talk about lighting and camera control and render settings in both Eevee and Cycles in another tutorial. I think this one was really just about topology and it's got away from me a bit. I really should get on with the Queen for our chess set, so we'll do that next. I hope you enjoyed this one.